In this lesson, we're going to look at how to find slope, and we're going to look at how to find slope from a graph, a table, from ordered pairs, and an equation, because you could have to find slope from any of those particular things. I also want you to look down here at the bottom. It says slope. Another name for it is rate of change. We refer to it as rate of change when we're dealing more with a real life situation. Slope is also thought of as a ratio, and when we talk about slope, we're talking about the steepness of a line. Some of you may already be familiar on how to find slope from a graph. There's more than one way you can do it, but I'm going to show you one particular way. You may have learned that in order to find slope, you can draw a right triangle. Remember, you want to pick 2 points, 2 exact points on the line. I know it's kind of hard to tell with this nice thick line, but those are the 2 points that I picked. And I'm going to draw a right triangle. That right triangle can be above or below the line. And then just like it says here, we're going to count the rise over the run, or you may have also learned the height over the base of the triangle. So the height here is 3, and the base is 2. So when I write my slope, and remember we use the letter M to represent slope, I'm going to write 3 over 2. When we're dealing with slope, most of the time we want it to be written as a fraction. So unless it was a word problem, I would not change that to a decimal. One thing we have to remember is that using our right triangle doesn't tell us if the slope is positive or negative. So we have to learn how to read our graphs. So I want to remind you that a positive slope always rises to the right, and a negative slope always falls to the right. So this rises right, and this falls right. Okay? I also want to mention that we can have a zero slope. A zero slope would be a horizontal line. The slope is 0. Something to think about when you see this, because we tend to get it confused. We would have 0 in our numerator and x on the bottom. Okay? And then we can also have no slope or undefined, and that is a vertical line. So no slope or an undefined slope. And when we write that, when we're working it out, we might get y over x. And you can think of this as like an upside down person. Okay, we can't do that. We don't want to be upside down. We're saying, oh no, I'm upside down. Okay, finding slope from a table. We can pick any 2 points. These are all coordinates. We can pick any 2 points to find the slope. It doesn't have to be ones right next to each other. I try to tend to find the positive numbers, but you can do whatever, and I'm going to show you 2 different ways, or 2 different things. So what I'm going to do is I'm going to find out how this is changing. To go from 4 to 8, we are adding 4. To go from 2 to 4, we are adding 2. So again, remember slope is the change in y over the change in x. This triangle is a delta, and it means change. So when I write the slope, what was my change in my y's? It was 4. What was my change in my x's? It was 2. And so then I would reduce that, and my slope is simply 2. It would be the same thing if I found it maybe between these last 2 points. To go from 10 to 16, we are adding 6. From 5 to 8, we are adding 3. So the way we get to 2 is a little bit different, but it's still the same slope. So I wanted you to see it doesn't matter which 2 points you use from the table. Okay? Finding slope from ordered pairs. Our slope formula is y minus y over x minus x. Now I want to point out that if you see this on a formula chart, it's going to have these numbers, y2 minus y1 and x2 minus x1. Those numbers are just naming your x and y because you have more than one ordered pair. The numbers are really irrelevant. We just have to make sure that we subtract our y's on top and our x's on bottom. So I want you to look at this example down here. If it's helpful, label your points. And again, very important, make sure that you're putting your y's on top and your x's on bottom. I'm going to show you two different ways that this might look. We can say -3 minus -6, those are my y's, over 2 minus 5. When I work that out, that's going to give me 3 over -3, which reduces to -1. So we have a slope of -1. What I want to show you is that I could have switched my numbers around a little bit. I could have also said -6 minus -3. Still my y's on top. I just switched which one I put first. And then 5 minus 2. Same thing. I just switched which ordered pair I started with first. This gives me -3 over 3. And so even though it looks a tiny bit different, it still has the same meaning of -1. The last way you might have to identify slope is from an actual equation. This is slope-intercept form. It is a form of a linear equation, y equals mx plus b. Remember, m stands for the slope, b stands for the y-intercept. And so all we have to do is make sure it's in slope-intercept form and then look at the equation to identify it. So right here, y equals mx plus b. Our slope is -2. Some people like to say that the slope is married to the x. So they're attached, they're married to one another. Okay, looking at the next equation, y equals 1/4 x plus 3. Our slope is simply 1/4. This one might be a little bit tricky. There is no number married to the x, or there's none appearing. Remember, when we don't have a number like that, it's understood that that is a 1, and so the slope would be 1. I want to point out that even if we took an equation and turned it around a little bit, this is still slope-intercept form. So rearrange just a little bit. And so I want you to see that this time our slope is over here, but it's still married to the x. So in that case, our slope would be -2.